Okay, so the last thing we're going to take a look at are the area of regular polygons. And just a reminder that a regular polygon means that all of the sides are the same and all of the angles are the same. So the first couple, it says each regular polygon has a radius and an apothem. But an apothem is the height of one triangle. So the general idea is that we're going to find the area of one triangle and then multiply that by how many of them there are. So in this first one, it says we are going to find the measure of each numbered angle. So if we take a look at this, these are central angles. So we have 1, 2, 3, 4, 5. This would be right. So it's the number of sides that the polygon has. So we have triangles, right? We have 1, 2, 3, 4, 5. This is 6, 7, 8. So we have 8 triangles inside there. So we're going to take 360 divided by 8 is 45. That means one of these central angles is 45 degrees. So angle 1 is a 45-degree angle. So it's a central angle. So angle 1 is 45 degrees. Now, if angle 1 is 45, if you take a look at this triangle right here, that 45-degree angle, because the triangle is regular, these would be like a radius. So those would be equal. So this is an isosceles triangle. So we're going to take that 45 and we're going to divide that by 2 is 22.5. And that would be what angle 2 is. So angle 2, right, we took 45 divided by 2 is 22.5. So angle 2 is a 22.5 degree angle. And then if you take a look at this triangle, angle, right, that's a right triangle, and we now have angle 2. So we can take 90 minus 22.5 to get angle 3 is 67.5. So angle 3 equals 67.5. Right, so then let's take a look at number 2. So on number 2, right, so we're gonna look at the number of sides, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides, right? So it's a nonagon. So we're going to take 360 and we're going to divide it by 9. And we're taking 360 because those would be central angles. So 360 divided by 9 is 40. That means angle 1 is a 40-degree angle. And then in this triangle right here, if we look at this one, right, that 40-degree angle, right, this angle would be 40. It gets cut in half. That means angle 2 is 20, right? We got 20 by taking half of 40. And then if angle 2 is 20, and then you see this little right triangle again right here, right, in that little right triangle. If angle 2 is 20, that means angle 3 would have to be 70. Right? So you're going to find the number of sides and you take 360 because those are central angles and the central angles add up to be 360. And then let's take a look at finding the area of each regular polygon with the given apothem A and side length S. So the general idea is that if we can find the area of one of these triangles and then multiply that by the number of triangles there are. So I said a pentagon, just a reminder, it's 5 sides, right? So if I just draw if I just draw one of these so you can see this, right? So if this is a regular pentagon, here's the idea, right? So it gets divided up into 5 triangles. So the number of triangles is always the same as the number of sides. And it tells us the apothem is 4.9. Remember the apothem, or apothem, some people say, is the height of one of those triangles. The height of one of those triangles is 4.9, and the side length is 7.1. So each side of this regular pentagon is 7.1. So we could take the area of one triangle. So we're going to take half. This side would also be 7.1. Like half the base times the height is 4.9. And then we have to multiply that by how many triangles are there. Well, we found the area of this one, and if it's regular, all of those triangles would be the same. So then we would multiply that by 5. So this is number 4. Right, so we're going to find the area of one triangle, and then multiply that by how many triangles there are. So we're going to multiply 1/2 times 7.1 times 4.9, right? That's the area of one triangle. And then times 5, because there's 5 of them. And so we have 86.975 square inches. So the amount of space on the inside of that regular pentagon. And then let's take a look at number 5, right? So we have a hexagon, and if I draw one of those triangles inside, like, so one of the triangles inside of the hexagon, and it says the apothem, right? So this is one of the triangles. So the apothem is the height of the triangle is 12.1 feet, and this, each side is 14 feet. So for the area, right, we're going to find the area of that one triangle, so half of 14 times 12.1. And then if it's a hexagon, it would have 6 triangles, right? So the number of triangles is always the same as the number of sides, right? So like in this pentagon up here, right, we have 1, 2, 3, 4, and then 5 equal triangles. So the number of triangles is the same as the number of sides. So we're going to multiply that by 6 because there are 6 triangles. So again, this is the area of one triangle. And then we multiply that by 6 because there are 6 of them. So we're going to take 1/2 times 14 times 12.1 for the area of one triangle, and then times 6 because there's 6 of them. So 508.2, and we're measuring in feet. So how much space is on the inside of that hexagon, right? So again, we're going to find the area of one triangle and then multiply that by the number of triangles there are. And the number of triangles is the same as the number of sides. So if you have any questions, again, Zoom meeting at 3 o'clock, and I can help you out then, or you can email me. Thanks. Take care.